Hey guys, Mr. Gran here with a video radical review. So with this, like the other review videos, pause, try the problems yourself, and then resume when you want to check your work or get a hint of how to get something started. Okay, so rewriting as exponent or radical form. So converting between the two forms. So this first one is in radical form. Remember that this x, if there's no exponent, it's x to the first, right? So the way this works, it would be x2, the exponent is the numerator, and the root is the denominator, so x to the 1/8. Now the next one, go in the opposite direction. We got to think, where does the numerator go, where does the denominator go? The denominator is the root, so there should be a 3 out in front here, and then the numerator is the exponent, so 5 to the 4th. And that could also be 3 root 5 with the 4 on the outside, but probably more likely you're using this one. All right, next one, similar to the first one, it is x2. The 4 is our numerator, and the 3 is our denominator. All right, simplifying. So making some factor trees with these. 448, now this is a fairly big number. It's even, so I know for sure that I can factor a 2 out. And 224 is also even, so 112, we still have a 2 that can be factored out. That is 2 and what, 56? 2 and 28, still even. 2 and 14. 2 down there, and 7. So that is a 2 down here. Let me get rid of that and try to make an actual 2. Kind of a long factor tree. All right, so now the root, right, is a 3. That means we're looking for groups of 3. So there's a group of 3. There's a group of 3. So 2 times 2 comes out, which is 4. And what stays in is the only thing I didn't circle, which was a 7. So 4 cubed roots of 7. That looks terrible. Let me redo that. 4 cubed root of 7. We'll highlight it instead. That's our answer. Okay, 5 times the square root of 75. So if we start factoring this out, well, I know it's divisible by 5. So that is 5 and what, 15? And if we go again, it would be 5 and 3. And so I'm looking for a group of 2, right? If it's a square root, there's no number here, you're looking for a group of 2. And that's 5. So a 5 comes out. There was already a 5 in the front, so that means it's 5 times 5, which is 25. And what's left is the square root of 3. All right, now this one. Little more to do with this. We're looking for a cubed root. 24 is divisible by 2, so 2 and 12, 2 and 6, 2 and 3. The x's, there's 6 of them, so 1, 2, 3, 4, 5, 6. 4 y's, 1, 2, 3, 4 y's, and a single z. Now I have a list of all of the factors here. I'm looking for groups of 3 because of the cubed root. So I've got a group of 3 2's. I've got 2 groups of 3 x's, and I've got a group of 3 y's. So everything I circled in red is going to move out in front of the radical. So 2, there's 2 x's, which would be x squared, and 1 y. And what stays on the inside is everything that didn't get circled. So the 3, a y, and a z. All right, next one. Multiply and then simplify. So we're going to start, so 2-part problems. We're going to start by multiplying what's on the inside, and then we're going to simplify it. So for this one, it is 3. 3 times 9 is 27. And then a squared times a squared is a to the fourth. Now if I factor that, 27 goes to 3 and 9, 3 and 3, and 1, 2, 3, 4 A's. I am looking for a group of 3 because it's a cubed root. And so what did I circle? I circled a 3, I circled one group of A's, and what I have left is a single A. All right, next one, I'll highlight the answer. Next one, same idea. X to the 5th times x cubed is x to the 8th, and then y to the 9th. All right, so now when I'm doing this, I've got 1, 2, 3, 4, 5, 6, 7, 8 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9 y's. And so my groups of 2, I've got 1, 2, 3, 4 groups of 2 x's. I've got 1, 2, 3, 4 groups of 2 y's, and 1 y left over. So this is going to equal x to the 4th for the 4 groups of x's, y to the 4th for the 4 groups of y's, and then that single y stays inside the radical. All right, next one. Okay, I got some stuff on the outside I need to multiply. 4 times negative 2, that is negative 8. Cubed root of 3 times 8 is 24. And z times z to the 4th is z to the 5th. All right, 24, that factors to 2 and 12, 2 and 6, 2 and 3. I'm getting kind of cramped at the bottom here, and then I've got 1, 2, 3, 4, 5 z's. I'm circling groups of 3 at the end of the factor tree branches, so that one's kind of goofy. And then the 3 z's. All right, so a 2 comes out. There's already a negative 8 out there, so negative 8 times 2 is negative 16. A single z comes out, and what's left on the inside is the cubed root of, I've got a 3 that was uncircled and 2 z's that were uncircled, so z squared. All right, add or subtract, and simplify. Well, and then we've got divide and simplify, and I think that's, oh, and then one more, okay. All right, so I want to simplify this first. I need to get the roots to, or the radicals to match, right? So if I start factoring this out, it is 2 and 12, 2 and 6. I'm going to stop factoring there because this 6 is what I want to match here, right? I know that 6 doesn't reduce the square root of 6, so I'm going to leave it like that, right? So I've got this group of 2, so that is going to equal, for the 3 times root 24, it is 3 times 2 on the outside, which is 6, and then root 6 plus 7 root 6. So now it's just like 6x plus 7x, except instead of x, it is root 6. All right, next one. Let's see. I probably need to get these two to match this. So I'm going to factor them to the point where I can have a 2 left over. Okay, so 20 is 2 and 10. 2 and 5, 2 and 4, 2 and 2, and actually this one is going to end up with 2 different roots. So we've got a 2 there comes out, and so what I have left is negative 3 root 2. The middle term will be plus 3 times 2 is 6. And what's left on the inside is root 5, and then minus 3 times 2 is 6, root 2. Now I can only combine the ones that match. I can't get this root 20 to be in terms of root 2. I can only get it to be in terms of root 5. So there's going to be 2 roots on this one, 2 terms. I can combine like terms here, which would be my negative 3 root 2 and my negative 6 root 2. So negative 3 minus 6 is negative 9 root 2, and then plus 6 root 5. And there is your final answer for that one. All right, divide and simplify. So looking at this first one, 170, we're looking at square roots. 175 and 7 are not square roots, so I think this one is going to be better to simplify it in one radical first. So I'm going to do this, and I'm going to reduce that. 175 divided by 7 is 25, and x cubed divided by x is x squared. So now 25, 5 and 5, x squared, x and x. Looking for groups of 2. This is a perfect square. So it's 5x. Everything got circled. There's nothing left over, so nothing inside the radical. That is our answer. Okay, with the second one, I notice that 81 and 4 are both perfect squares. If I factor those out, it's 9 and 9 and 2 and 2. I almost wrote 4 and 4. And so, like, the top simplifies to just 9, the bottom simplifies to just 2, and then boom, I'm done. 48 and 6, however, 48 and 6, neither of those are perfect squares. I think this one is going to be better if I do 48 and divide it by 6. 48 divided by 6 is 8. 6 times 8 is 48, so 48 divided by 6 is 8. And now I can simplify this and it'll work a little bit easier. 2 and 4, 2 and 2. I've got one group of 2, one left over, so this is 2 root 2. All right, last one. This one again, I'm going to divide this out first. I'm going to simplify it inside the radical first. 60 and 15 are not perfect squares. 60 divided by 15, though, is 4. And x to the 6th divided by x squared is x to the 4th. 4 factors to 2 and 2. 1, 2, 3, 4 x's. And there are my groups of 2. Everything gets circled. What did I circle? I circled a single 2, a group of 2. I did 2 groups of x's, and so 2x squared. All right, there you have it. Let your teachers know if you have any questions, and have a great day.